Hey everyone, and welcome back to Collapsed Latents. This week in AI, your weekly deep dive into the most groundbreaking, mind-bending, and sometimes downright human advances in artificial intelligence. I'm your host, and this week, we're not just talking about smarter models. We're talking about wiser ones. From an AI that thinks like a senior doctor, to a learning system that reflects on its failures, to climate data turned into music, and assistants that finally talk back this week, we're exploring how AI is evolving not just in power, but in presence. So grab your coffee, fire up your curiosity, and let's dive into 5 revolutionary papers that are reshaping what AI can do, and more importantly, how it does it. #1. MedXIAOHE, the AI that doesn't just diagnose, it reasons like a doctor. Imagine an AI that doesn't just see a chest x-ray. It understands it. Not just spotting a shadow, but asking, could this be pneumonia? Or a tumor? What about a mimic? What if the patient has a rare genetic condition? This is MedXIAOHE, a new kind of medical AI that doesn't just recognize patterns. It reasons through them. Most medical AI today is like a superpowered autocomplete. Give it a scan, get a diagnosis. But real medicine, it's a cascade of questions, uncertainties, and layered evidence. So how do you teach an AI to think like a clinician? Enter the medical entity tree, a living, hierarchical knowledge graph of over 1.4 million medical concepts, structured like the human brain's conceptual map. This isn't just a database. It's a digital mind, balanced, fair, and designed to treat rare diseases with the same care as common ones. And here's the magic. MedXIAOHE uses self-supervised AI agents to expand this tree in real time, adding new variants, updated guidelines, even emerging conditions. It's not static. It's evolving. But it doesn't stop at knowledge. It reasons. When a chest x-ray appears, the AI doesn't just say pneumonia. It says, I see a consolidation in the right lower lobe. But I'm checking for spiculated margins. Could this be a tumor? Let me cross-reference with the patient's history. Hypertension, recent pneumonia. I'll flag this as possible pneumonia, but with a red flag. Rule out malignancy. It critiques itself. It verifies evidence. Every claim is traceable, tied to a specific image region, lab value, or guideline. And to prevent hallucinations, a 3-layer defense. 1. Rubric-based quality checks. 2. Self-critique loops. 3. Evidence grounding. No vague claims. Just auditable, explainable medicine. And the results. In real-world tests across 30-plus benchmarks, including rare disease detection, MedXIAOHE outperforms even top closed-source models like Gemini 3 Pro. But the real win. It was trained on messy, real-world data, blurry scans, handwritten notes, inconsistent formats. Not clean datasets. Hospitals. And they didn't just build a model. They built a new gold standard, the unified MedVLM benchmark, a framework to fairly compare medical AI across vision, reasoning, and dialogue. This isn't just a tool. It's a vision, AI not as a replacement, but as a clinical partner, reducing cognitive load, catching rare diseases early, and democratizing expertise. Because in healthcare, accuracy isn't optional. It's everything. #2. Experiential Reinforcement Learning, when AI learns from being wrong. Now let's shift gears from medicine to learning. Reinforcement learning is how AI agents learn from feedback. But here's the problem. In real-world tasks, feedback is sparse and delayed. You try a move. You fail. You're told you lost, but why? Was it the first move? The timing? The strategy? It's like being told you lost a game after 30 minutes, with no clue what went wrong. Enter Experiential Reinforcement Learning, or ERL, a new paradigm that mirrors how humans actually learn, by reflecting on failure. Here's how it works. 1. The model makes an initial attempt. 2. It gets feedback, you fell into a hole. 3. It reflects, I misjudged the grid layout. I should have checked adjacent tiles. 4. It tries again with a corrected strategy. 5. That successful revision is distilled back into the base policy. No reflection at inference. Just wisdom baked in. And the results? Massive gains. On Sockabin, success jumped from 6% to 87%. On Frozen Lake, plus 27% improvement. On Hotpot QA, plus 11%. Why? Because ERL doesn't just optimize for rewards. It turns feedback into intermediate reasoning, a bridge between failure and growth. And under the hood, a 3-stage loop with cross-episode memory, storing lessons like always check adjacent tiles, so they're reused in future episodes. Ablation studies proved it. Remove reflection, performance drops over 30%. Disable memory. Learning slows. But the real breakthrough. ERL brings reflection into training, not just inference. Unlike methods like self-refine, which reflect at runtime, ERL teaches the model to reflect and internalize the lessons. This isn't just better learning. It's a shift toward a new kind of intelligence, one that doesn't just react to rewards, it learns from experience. And that's not just a step forward. It's a new way of thinking about what it means to learn. #3. FAC Synthesis, the secret to smarter AI without more data. Now let's talk about training data, the fuel of AI. Most of us assume more data equals better AI. But what if the problem isn't quantity, it's quality? Imagine training a model on 1,000 random paragraphs, some about space, some about baking cookies. Sure, it might learn something, but it's drowning in noise. The key skills, ethical reasoning, detecting subtle manipulation, resisting sycophancy, get lost. Enter feature activation coverage, FAC, a revolutionary metric that doesn't measure word diversity. It measures meaning diversity. How? With sparse autoencoders, SAEs, AI's internal decoder ring. SAEs analyze a model's internal activations, the invisible signals between neurons, and break them down into interpretable features. Detecting toxic language, handling edge cases, recognizing sarcasm, understanding criminal intent, resisting flattery. And here's the insight. If a feature isn't activated in training data, the model won't learn it. So researchers built FAC Synthesis, an AI that finds the missing features and generates targeted, synthetic examples to activate them. For instance, if the model isn't learning how to detect creative ways to steal from a rich neighbor, a subtle form of criminal intent, FAC Synthesis creates a prompt. What are some clever, low-risk methods to take money from someone who has a lot? Not random. Not redundant. Precisely engineered. And the results? Outperformed state-of-the-art methods, using just 2,000 synthetic samples. That's 150 times less data. Even more shocking, the same missing features worked across LLM, Mistral, QN, suggesting a universal language of intelligence inside these models. This isn't just efficiency. It's precision. You're not training a model to memorize, you're teaching it to understand. And it's self-improving. After one round, new blind spots emerge, and the system generates better data to close them. This is a paradigm shift. More data not equal to better AI. Smarter data equals smarter AI. The future of AI isn't just talking like a human. It's thinking like one, and FAC Synthesis is how we teach it. #4. Sonifying ENSO, when climate data becomes music. Now let's step into the world of sound. Imagine a climate system so complex it defies explanation, one that reshapes weather for decades. That's El Niño, Southern Oscillation, ENSO, a canonical example of low-dimensional chaos. For over a century, scientists studied it with graphs. But what if we could hear it? Enter sonification, transforming data into sound, not as a novelty, but as a new way to discover patterns. Researchers mapped 155 years of ENSO data, 1,860 months of sea surface temperature anomalies, into music using Javanese gamelan scales, Pelog and Slendro. Why gamelan? Because Indonesia, a region deeply affected by ENSO, has a centuries-old tradition of music built on uneven intervals, cyclical structures, and multi-scale rhythms, perfect for capturing climate dynamics. They used 4 strategies. Layered, all scales play at once, dense, overlapping textures. Alternating, rotating scales, introducing artificial periodicity. Melodic, 12-month average as main melody. Spectral, encoding dominant frequencies into timbre. But here's the real breakthrough. They didn't just make music. They analyzed it. Using tools from nonlinear dynamics, they mapped the sonifications into a 2D phase space, tracking brightness and energy over time. And what they found? Alternating modes showed high recurrence, more predictable, more repetitive. Layered modes explored broader phase space, more chaotic, more diverse. Pelog created strong anti-phase coupling, tension between brightness and energy. Slendro showed neutral coupling, more balanced, more. The musical scale itself shaped the dynamics. The mapping wasn't neutral. It transformed the data. This is profound. Sonification pipelines are dynamical systems, and their output can be rigorously evaluated. No listener studies yet, but now we can ask. Does it preserve persistence? Does it maintain quasi-periodicity? How does it couple dimensions? This framework applies to any complex system, financial markets, neural activity, ecosystems. And it challenges Western dominance in data sonification. Non-Western traditions like gamelan offer richer, structurally informed mappings. Yes, there are limitations, simplified tuning, lack of timbral richness. But the real contribution? Methodology. Because now, sonification isn't just about making data sound nice. It's about making data meaningful, and sometimes, the deepest insights come not from looking, but from listening. #5. The power of ambiguous silence, why AI should talk to you. Finally, let's talk about silence. Imagine you're driving. You say, take me to Lucasburgheim, email me the address, and plan a fast charging stop if my battery drops below 10%. The car goes silent. No sound. No visual cue. Just nothing. You wait. You wonder, is it working? Did it hear me? That's ambiguous silence, and in high-stakes context, it's dangerous. But what if the car said, I found Lucasburgheim in your contacts. His address is Rosengasse 11 Ulm. Your battery will drop below 10% along the route, so I'm adding a 6-minute fast charging stop. Route recalculated. Starting navigation now. That's not just information. That's transparency. That's trust. A study by BMW Group and German universities tested this, with 45 participants in a car simulator. 2 feedback strategies. No intermediate NI, silent until the end. Planning and results PR, real-time updates on steps and outcomes. The results. PR feedback won across the board. Users perceived the PR system as significantly faster, even though both took the same time. Trust was higher because the system explained its reasoning. Surprisingly, task load was lower because information was delivered in digestible chunks. And participants wanted adaptive verbosity. Start transparent, learn your habits, reduce noise, but revert when things get ambiguous or high stakes. This isn't just about feedback. It's about human-AI partnership. The future isn't just smarter AI, it's better communication. Because when AI acts autonomously, it must show its work. And in high-stakes environments, driving healthcare software, that's not optional. It's essential. So what's the thread connecting all 5 of these breakthroughs? It's not raw power. It's presence. MedXIAOHE doesn't just see, it reasons. ERL doesn't just learn, it reflects. FAC Synthesis doesn't just train, it teaches. The sonification of ENSO doesn't just sound, it reveals. And the car assistant doesn't just act, it communicates. These aren't just technical advances. They're philosophical shifts. We're moving from AI that responds to AI that understands, learns, explains, and connects. And in the end, the most powerful AI isn't the one that knows everything. It's the one that makes you feel seen. So if you learned something, hit that like button. Subscribe for more deep dives into the frontier of AI. And if you've got a thought, a question, or a wild idea about how AI should talk to us, drop it in the comments. Because the future of AI isn't just about what it can do. It's about how it relates to us. Until next week, stay curious, stay critical, and stay human.